Ladies and gentlemen, in this video, present an example of learning mathematics by applying model discovery learning for junior high school student in 8th grade and for material theoretical and experimental probability. My name is Zulia Ningtyas. I'm from Math 17 and my last register number is 002. Discovery learning have 6 syntax. The first is stimulation, problem statement, data collection, data processing, verification, and generalization. To be clear, let's see the video about simulation of discovery learning in theoretical and experimental probability. Happy watching! Assalamualaikum class.
Waalaikumsalam, Miss.
How are you today?
I'm fine, Miss.
Okay, good. Before we start our class today, let's pray together. Pray, stop. Finish. Okay, today we will learn about new chapter in mathematics. It's all about probability. In the daily life, do you usually find statement that consists of probability?
Yes, Mom.
What statement is that? Could you please mention statement about probability?
Statement, today it will rain, Miss. And when in carnival, Miss, play a roulette or spinner, then we hope to get the main prize. Is that about probability, Miss? Probability to get the main prize.
Yes. The statement that you have mentioned before is all about probability. But actually, I think you just know the probability as the possible. So let's think about it. If I have statement like one day human will be die, and if we throwing a die is a singular of a dice, we will get a number of die. What do you think about those statements?
I think we certainly will die someday. And for throwing one die, we will never get 8. Because a die just have maximum 6 number of die.
Yes, that's correct. Actually, those statements that I've mentioned before and your statement is all about probability, but we categorize all the statements into 3 groups, which is impossible, possible, and certain or absolute. Do you understand?
Yes, Miss.
And in mathematics, we give the value of the categorized from for impossible that will never happen in the real life. We give value of 0. 0 is for impossible. And 1 is for certain or will happen, certainly happen one day. So how about the possible?
It lies between impossible and definitely happening, Miss.
Yes, it plays between 0 and 1. Here is the possible. So what you get from here?
The value of probability is from 0 and maximum is equal to 1.
Yes, because we just have 3 categories in here, from impossible, possible, and the certain happen. Okay, you understand?
Yes, Miss.
Now, I want to recall your memory about ratio. Do you still remember about ratio?
Yes, Miss.
Yes, because we will use that concept in probability chapter. So before that, I will give you some statement. So here I have three statements. The first is a coin flip is considered a 50-50 change because there is an even 50% chance of a head appearing as well as 50% chance of tail to appear. And the second, a 5-color spinner is considered 1:5 ratio change for each color, or it has 20% change for each color to appear. And third is a die is considered 1:6 ratio chance to appear for each number of die. To understand about probability, I think let's criticize the first sentence. Here we have chance of appearing head and appearing tail is 50%. So I can write head just then tail. The chance is 50%. And also tail is 50%. Actually, I can rewrite this form into fraction because 50% is equal to 50 over 100. And this also 50 over 100. Or I can write head is equal to 1 over 2. And tail also 1 over 2. To understand what that means, do you still remember about fraction? If I have a cake and I divide this cake into two equal parts, what the part is it?
A half, miss.
Yes, a half. So take a look back with this case. What does it mean with head equal to 1 over 2 or a half?
1 is represent the number of head and 2 is represent the number of head or tail.
Yes. Good answer, Sandy. It's number of head and tail. And in the probability terms, we call the number of head with even, and the number of head and tail is the possible outcomes, or the symbol in probability is S for the possible outcomes, and the even is A. And the number of even we call them as an A, and the number of possible outcomes we call as N X. Do you understand?
Yes, ma'am.
Okay, for your information, we call possible outcomes in probability language as sample space. Could you repeat after me?
Sample space.
Okay, sample space. Okay, can you tell me what is the sample space of this case and how many number of the possible outcomes?
Actually, there are two possible outcomes, miss, which is head or tail.
Oh yes, I can write as H and T represent H for head and T for tail, and the possible number of possible outcomes is equal to 2. And how about the second one, Sandy?
For rolling a 5-color spinner, there are 5 possible outcomes, miss.
5 possible outcomes. And the sample space, it could be the first color, second color, third color, fourth color, and the fifth color. And how about the die? The third statement.
6, miss.
The number of possible outcomes is equal to 6. What is that? 1, 2, 3, 4, 5, and 6 number of die. So very good, Sandy. I have question for you. if we toss two coins, how many number of possible outcomes are the sample space?
2, isn't it, Miss?
2. So you think that it has sample space with if we toss one coin, right? So to answer that, let's imagine this. If you have two coins and you toss together, it could be the first coin show head and the second coin show tail. But it's also possible if the first coin show head and the second coin show head too. So if I list, it could be here. The sample space if we toss 2 coins, it could be the first coin is head, the second coin is also head, or the first coin head and the second coin is tail. The first it could be tail and the second is head, or it could be both of them is tail. So how many possible outcomes in here if we toss 2 coins?
So there are 4 possibilities.
Yes, there are four possible outcomes. So be careful to determine the sample of space. Better you list them first before you say how many number of the possible outcomes. So do you understand?
Yes, Mom.
Actually, our discussion is all about theoretical probability, and the three statement here also told you about theoretical probability. So you have learned about what is even, what is possible outcomes, and how can we determine the sample of space. So now, to find the theoretical probability, what will you do?
I think to determine a theoretical probability, we need the number of all possible outcomes, Miss.
Okay, all number of possible outcomes. So I write an S in here and the symbol of theoretical probability I write as PA. And then what you need?
Then we can make the theory with the number of events that we want to know and number of all possible outcomes.
Okay, good. So here, if you want to find the theoretical probability, we need to make ratio between the number of events and the number of all possible outcomes. So you can determine theoretical probability by yourself.
Yes, Miss.
Okay, good. I have a question for you. If you toss a coin for real and you do that for more than one more time, could you have the same value of probability as the theoretical probability?
It could be, Mom.
So how about the second statement? If you roll spinner for real and you do that more than one more time, could you get the chance is 20%?
Yes.
And how about a die? If you throwing a die, could you get a chance 1 just then 6?
Maybe yes, Mom.
But you look so uncertain. So here I have worksheet for you, and in here you have to do flip coin for 30 times and roll one die for 60 times and spin 5 color spinner for 100 times. This worksheet is also guide you to test your hypothesis, as you think that if we toss or if we do this activity for more than one more time, we get the value as the theoretical probability. So you can fill this and you do the experiment for real. So I'll give you application coin, rolling a die and spinning 5 color spinner. And then in here, you have to find the ratio between the number of outcomes and the number of experiments you do. And then you write your hypothesis in here about the chance of this activity, and then you write the result, what you get from the experiment, and you can write your conclusion, and then after that you must show me about your results in front of the class. Okay, you understand?
Yes, Mom.
Okay, so let's do it. Okay, I will explain to you how to use this application to help you solve and fill the worksheet. So here for the 5 color spinners, and how to use it, you just click spin in here and wait until what color does the spin stop. What the color is it? Yellow. And then here yellow, you give 1 stick in this column. You understand?
Yes, Mom.
Okay, good. Okay, for a coin and a die, I'll give you option. You choose to fill this or do this experiment with application or using real coin and real die.
Application, ma'am.
Okay, if you choose to use application, so I'll explain to you how to use it. So you open this and then you choose the coin. After that you just click here and what you got is tail, and you give 1 stick in tail even. Understand?
Yes, Mom.
Okay, and for the die, you can choose this die roll. And then just click here. Then you get 4, and you get 1 stick in. What is it? Understand?
Yes, Mom.
Okay, you can start to do your experiment. Have you done with your experiment?
Yes, Miss.
Okay, so please come forward and share about your result.
My result. After 30 times flipping a coin, 100 times rolling a 5-color spinner, and 60 times throwing a die, I got the result like this. For a flipping a coin, the number of heads appears is 12, and we can calculate the ratio between the number of heads appears and the number of experiment is 12 over 30. Besides that, the number of tail appears is 18, and we can calculate the ratio between the number of tail appears and the number of experiment is 18 over 30. There are a little bit different than the value of theoretical probability, which is 1 over 2 for each part coin. Die. Number die 1 appears 11 times, so the ratio with the total trials is 11 over 60. Number die 2 appears 12 times, then the ratio is 11 over 60. Number die 3 appears 11 times, the ratio is 10 over 60. Number die 4 appears 6 times, the ratio is 6 over 60. Number die 5 appears 10 times, the ratio is 10 over 60. The last number die is 6, appears for 11 times, so the ratio with the total trials is 11 over 60. This experiment also have a little bit different value of probability in each number of die than the value of theoretical probability, which is 1 over 6 for each number die. Then about the spinner rolling for 100 times. The red appears 20, then ratio is 20 over 100. The green appears 20, then ratio is 20 over 100. The yellow one appears 20 times, so the ratio is 20 over 100. The blue color appears 22 times, then the ratio is 22 over 100. Last color, purple, appears 18 times, then the ratio is 18 over 100. Is this experiment for rolling a 5-color spinner also have a little bit different than the theoretical probability?
Yes, I see the difference, Sandy. Now, what do you think about the value between your value experimental probability and the theoretical probability?
After finish this experiment, Mom, I get serious with the value, so I changed the value in the experiment into decimal and also the theoretical.
Okay, good step. Then what you get, Sandy?
If in doubt, it has a little bit different, but actually the value of experiment probability is approaching the value of theoretical probability.
That's right. So tell me about the relation of experiment probability and the theoretical probability and how to calculate those probabilities.
I think theoretical probability is about our prediction of an event.
Okay, good.
We just focus to make ratio between the number of event outcomes and the number of possible outcomes. It can be written as
Okay, good.
If the experimental probability, we do the experiment until we know the number of outcomes. After that, we can make the ratio between the number of outcomes and the total trial. Although there is difference in theoretical probability and experimental probability, but actually the value of experimental probability approaching the theoretical probability. In the other word, the experiment approach the true theory, isn't ma'am?
Yes, Sandy. The theoretical probability is the ratio between the number of event with the number of all possible outcomes. We can write as your written like that. And then the experimental probability is the ratio between the number of outcomes in the experiment and the total number of experiments. So Sandy, your explanation is correct. So thank you.
You are welcome, Miss.
Sandy, I have question for you. See that the experimental probability in flip coin and roll one die is different with the theoretical probability. But why the red color in spin a 5-color spinner has the same value in experimental probability and theoretical probability?
I don't know, Miss.
You don't know. So I think you correct say that the experiment is approach the theory, but the approach it can be has the same value with the theoretical probability. So that's the answer. So it's not just about different, but it can be equal to. Do you understand what I mean, Sandy?
Yes, Mom.
Okay, good. So yeah, we have learned about theoretical probability and also experimental probability. We know how to calculate them and we know the relationship between the theoretical and the experimental probability. Okay, so I'll review again about the theoretical probability is about the prediction. So we calculate it with the formula, math formula, which is PA is the theoretical probability is equal to the number of event over the number of all possible outcomes. And the experimental probability is about the probability that we get from experiment. We do a trial. So how to find the probability is the number of event that we want to know the probability over the number of trial. And the relationship is that the experimental is always approaching the theoretical probability, I mean the value. So do you understand?
Yes, Mom.
Okay. No question about this?
No, Miss.
Okay. I think enough for today. And then to review about our lesson today, I'll send a quiz into Google Classroom and you must submit it before 12 p.m. today. And thank you for your attention. May Allah always protect you from COVID-19. And Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. my result. After 30 times flipping a coin, 100 times rolling a 5-color spinner, and 60 times throwing a die, I got the result like this for a flipping a coin. Sudah.
So, any question? No?
No, yes.
Okay. I think enough today. So may Allah always protect you from COVID-19 and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Hapus lagi.
The number of head keepers. Bentar. Ya, Mbak. I will show my result. After 30 times flipping a coin, 100 times rolling a 5-color spinner, and 60 throwing a die, I got the result like this for a flipping a coin. The number of head apples is 12, and we can calculate the ratio between the number of head apples and the number